So now we're going to discuss questions 15 from topic 5. Ferris wheel with 38-meter radius, tangential speed 5 meter per second, has a mass of 76 kilogram. Passenger riding on it. So the question asks you, what is the magnitude of centripetal force acting on the Ferris wheel, top and bottom? So centripetal force is constant when the object moves in uniform circular motion. So in other words, I straight away use one equation. Centripetal force is equals to mv squared over r, and these values are the same if for passenger at the top and the bottom. Substituting in the mass. So the mass here is 76 kilogram multiplied with the speed is 5 meter per second squared divided by the radius is 38. So from here, we will be able to get 50 Newton centripetal force. Okay. B, the question asks you to draw free body diagram showing the forces acting on the passenger, top and the bottom of the Ferris wheel. Indicates we have to state that the apparent weight is greater, equal or less than the true weight. So what is apparent weight? Apparent weight refers to normal force. So whatever we found our weight is based on normal force. So if the normal force higher, then we feel a bit heavier, right? That is your apparent weight. So if I draw the free body diagram, right? So two position. So person sitting on the Ferris wheel, at the bottom and at the top. So what I do is, one is sitting at the bottom, the other one will be sitting at the top. Right? So I'm going to draw free body diagram act on the person at the bottom. So at the bottom that would be normal, that would be weight. So weight I'm going to put it as mg. At the top, similar things. Normal is at the top, weight is downwards. So this is the two free body diagram, top and bottom. So what happens if you want to construct equation? So we start off with the bottom. So at the bottom and the top. So at the bottom, if you refer to here, so the normal and weight is opposite direction. So your centripetal force will be equals to normal minus weight. Why normal minus weight? So because when the object be able to move in circular motion, the net force or the bigger force must be directed towards the center of the circle. So in this case, the center of the circle is from normal. So normal must be bigger than weight. If I rearrange, I will get, and now my equation will become centripetal force plus mg. So since that the centripetal force is the one we have calculated early on, part A, so we can see that the normal force, which represent our apparent weight, is bigger than the actual weight, which is mg, right? Because we have to plus the centripetal force. So we can say that the normal at the bottom here is more than your actual weight, which is the mg. So we will feel a bit heavier at the bottom, right? So at the top, so we will look at the equation, free body diagram at the top. So mg and normal is opposite direction again. So our equation for centripetal force will be equals to, this time is equals to mg minus with normal. So why mg minus with normal? Now because mg is directed to the center of a circle. So the net force must be directed to the center. That means that this value must be bigger than normal. Right? So rearrange the equation. I will end up with normal is equals to mg minus with centripetal force. So you can see here the apparent weight, which represent our normal, is smaller than the actual weight. Why? Because we need to minus the values of centripetal force. If you're wondering what is the centripetal value, it's 50 Newton from the one we have calculated early on. So we can say that n at the top here is less than the actual weight. Right, the actual weight. So we know that bottom is bigger than the actual weight, top is less than the actual weight. That is your apparent weight for top and the bottom. So C determine the normal force exerted on the passenger, top and the bottom. So now we need to calculate the value itself. Right? So I'm going to proceed from here. So C, looking at here, the equation at the bottom. So I'm going to refer to this equation. Right, this equation. So the bottom normal is equals to Fc plus mg. So substitute in the value of centripetal force is 50 Newton from the one we have calculated in part A, plus mass is 76 kilogram, 9.81 gravity. From here, I'll be able to get my normal force, 795.56 Newton. Right? At the top, referring to the equation that we have derived early on, this one, normal force will be equals to mg minus with centripetal force. Substitute in mass g minus with centripetal force, which is 50. I'll get my value will be 695.56. This is the normal force at the top. Right? Last part, D. How fast would the Ferris wheel have to go for the passenger to feel double? The key word would be the not to feel. That means that there's the apparent weight must be double of the true weight, right? So at the bottom of the Ferris wheel. So I'm using the equation at the bottom of the Ferris wheel. So bottom equation will be N is equals to Fc plus mg. Now, in order to the passenger to feel double is of apparent weight, double of its actual weight, normal must be equals to 2 mg. So that means that the apparent weight or the one that I felt is double of the actual weight. So substitute in our end up with 2 mg equals to Fc. I'm going to expand this one to become mv squared over r, so that in order to calculate the speed, plus mg. So if I move mg to this side, so 2 mg minus mg, you end up with mg only, mv squared over r. So m can cancel out both sides. Rearrange the equation. I will end up with rg and then square root. Substitute in the value of r, radius 38, g is 9.81, square root. So I end up with 19.3 meter per second. So this is the speed